Great. We are starting now with the afternoon session of the BioDataScience 101 webinar. I hope that you had a nice rest. It was an intense morning for sure. Can you guys hear me? Super. Great. We're starting now with the afternoon session. I can anticipate that this is going to be a bit easier than the morning session. So we have thought about you after lunch or probably after dinner for people that are in China. We wanted to take things a bit, on a slower pace. And let's get started. Can you all see my Jupyter Lab interface? Great. So what I will do is that I will copy Module 2. Put it in my folder, and I will quickly explain the learning objectives and the data set that we are going to analyze for Module 2. Now, the main idea for Module 2 is to learn some useful skills to visualize data. In Module 1, we had a little bit of data visualization. We'll kind of continue in that direction on a new data set. Again, no worries if you will not be able to finish the complete notebook now, because the notebook will be available for 1 week of time. We will also share the videos so that you can also go back and listen to all the discussions that we have had. Great. So the learning objectives for this second session are to handle sequence data, in particular protein sequence data, so amino acids, to encode amino acid data in an efficient way so that it can be analyzed and visualized. We will use a new library that is Seaborn, that it's a very simple library for visualizing data. And we'll also use a little bit of Matplotlib, that it's a very fundamental library in Python for visualizing data. And the main idea here is to analyze sequences that are coming from different organisms that grow at different temperatures. So we all know that in most of the cases, organisms usually grow nicely in a range of temperatures that goes from 20 to 37, that is the body temperature. And this is kind of a normal range for organisms, but we also have some organisms that can grow at much higher or much lower temperatures. Why this is important? Because in general, whenever we have proteins, they are stable usually at in a given range of temperatures that it's around the normal temperatures, like 20 to 37. If you increase the temperature, usually you destabilize the protein. So that's why in a lot of cases, organisms don't grow or can get can also die if you increase the temperature, because protein starts to denaturate, to misfold. And at the beginning, you need to use a lot of energy in order to refold the proteins. And at some point, when the temperature is too high, the organism is not able anymore to have all the protein folded in a correct way. And we would like to understand what are the features in proteins that are expressed by organisms that grow at very high or very low temperatures, so that those proteins can be stable and work and function in such extreme ranges. This is not only interesting from a, let's say, purely biological point of view or biochemical point of view, but it's also important, for example, if you want to engineer an enzyme so that it works at high temperature. For example, you want to engineer an enzyme that is used to as a part of the formulation for detergents, for example, so that it can work at higher temperatures and be more efficient in washing things, right? So this is all explained at the very beginning of the notebook, and the dataset that we're going to use is called the protein heat resistance dataset. It is a dataset that is coming from this Kaggle competition. For the people that don't know about Kaggle, Kaggle is a website that is posting challenges, meaning that they are posting data sets on which people can try and do their best to develop prediction methods. And after a given given time frame, people can actually see how good they perform, because the managers of Kaggle, they have external data set on which to see how well each method has performed. Go in the Kaggle data set, try, if you have time, to also try to play around with some of the data. It's extremely, nice to try to challenge yourself with this kind of data. It's not easy, and since there is also a prize for the groups that kind of perform the best, there is a lot of competition. Anyways, going back to the data set, we can see from the Kaggle description that the data consists of the sequence of proteins as input and the growth temperature as target. So you have protein sequences and growth temperature. The sequences are coded as numbers from 0 to 20. We'll see what this means. The numbers 1 to 20 relate to the canonical amino acids, which are present in every cell. The class 0 encodes known. Note that protein sequences vary in length. Therefore, shorter sequences will have many zeros at the end. The dataset contains more than 7 million sequences with a related temperature. Now, our aim for this module is to, first of all, read the data, try to understand how to encode sequences in a way that is optimal to make statistical analysis and visualization, and trying to get a feeling of how the data looks like, trying to get a feeling of which kind of features present in the different data sets, that is the organisms that grow at low, medium, and high temperature, might affect their phenotype. I think that's it for me. Try to go through the notebook. It's a bit shorter than the other one, so I hope that you will have a easy time going through it, and we will be available for for questions, and we will be back in a little bit more than 1 hour to go through the notebook and to discuss, as before, some small details about the tasks that we perform. Thanks, and see you later.